Let's start now by looking at a very fundamental type in MATLAB, which is the array type. Actually, arrays and matrices, we've seen the term matrix before, which is a regular table, two-dimensional table. Arrays and matrices are, these concepts are interchangeable in MATLAB. So from now on, we're effectively talking about the same thing. So we're not gonna differentiate between both. An array is potentially, it is a collection of data. It could potentially be n-dimensional, which means it is an object that is organized in n dimensions. Now, each dimension has a fixed size. So if you want to do the comparison, it is really similar to the notion of a rectangular table that we talked about in Python. This is a matrix. It cannot be a list of lists with variable sizes of each list. No, actually, every dimension has a fixed size. Or you can think about it from a different perspective in the sense of the size of every entry in every dimension is completely filled to the largest of all of them. These are very fundamental types in MATLAB. And the reason why they are very important, very fundamental, is that MATLAB is built actually to work directly on arrays. So when we pass or when we deal with arrays, the operations are actually very efficient. So let's start off by building arrays of, let's say, zeros and ones. The syntax for building an array of zeros, so I'm gonna comment out temporarily those two commands. So when we build an array of zeros and we run this, we're gonna get an x, and I'm taking out the semicolon so we can get x displayed, or we could have written this x. So when we're printing x, you can see in here, we're creating ones that has 7 rows and 1 column, and you can see in here, and all of them are 1, so 1, 1, 1, 1, 1, 1, 1, etc. Right? We could have actually built in here an array that has zeros instead of ones, and we simply write zeros and we specify, as you can see in here, the number of rows and the number of columns. So 5 by 8 regular table that is filled with zeros. And by the way, is a very interesting command in here that you should be aware of. That is whos. Whenever we run whos, actually it displays for us the variables that are currently in use. So we say, okay, there is something called I, because we did execute it in a previous lecture. There's something called S, and there's a variable called X. And then you can see in here, it is 5 by 8 and 320. So that's for the sake of this example. I'm going to start with Y in here. And when we execute whos, you can see that we have X that is 5 by 8, and we have Y that is 7 by 1. So whos will give us a list of the variables, their dimensions, their size and memory, their types, which is a great thing to have in case you're not tracking what are the variables, what are the things that are being currently in use. Now, we can use the colon operator to list consecutive, to build, to generate consecutive numbers. So when we write Y, colon 10, and we execute it, this is going to be 1, 2, 3, all the way to 10 inclusive. So x equal 1 colon 10 is going to be an array that is one line that is 1, 2, 3, all the way to 10. Now, if you would like to generate something similar, but to jump by a step, then we can use the syntax of a colon, some step size, let's say delta, and another column. This is going to generate a list that are separated by delta. So take a look at this. If we write y equal 1, and we put column to column 10, and we execute this, we're going to get 1, and then the jump is by 2, 3, and jump by 2, 5, 7, 9. So this is one way of generating arrays using the colon operator. In some sense, it's as if we're saying, if you use one column, it's as if we're saying there's a step size of 1, but you can specify the step size you want. Of course, it can be, the step size can be negative as well. Now, also to generate arrays, we can use the linspace method for array construction. And this is slightly different. Linspace takes 3 parameters. The last one is the number of elements that will be generated, the size of the array. So n is going to be the number of elements. It's going to be n times n by 1 array. It will start at number s, and it will end at number e, and they will be equally spaced. So linspace 1 to 11 will generate actually 11 numbers starting at 1 and ending at 2 inclusive, and they are equally spaced, right? So you can specify in here any n you like. And again, you start from the position, the value S, the end value 2, and this is going to be 21 numbers that are equally spaced. All right, so if you would like to construct an array-specific array, or let's say literal array construction, you want to say this is the array specifically that I'm dealing with, well, we can use a square bracket. So we write x equal, here's a square bracket open, square bracket closed, and we specify the content of the array. Now, this could be one-dimensional, could be multi-dimensional. We use comma to separate columns. So if we write something of this form and we execute it, then x is going to be 1. It is going to be 1 row and 3 columns. The comma separates the columns. So entry 1, 5.2, 9.7. You can also use the semicolon to separate rows. So in this case, we can add a semicolon in here and list 3 additional numbers separated by commas. And this means actually we have 2 rows. The first row is 1, 5.2, 9.7. The second one is 3.4, 9.3, and 10.7. This is how we construct explicitly an array, 2-dimensional array in this case, with specific data entries. Now, very interesting thing here when it comes to indexing, and I don't know if you would prefer something like this, but it is, from this perspective, kind of better than Python. There's no off by one indexing. We don't start from 0 like in Python. Actually, we start with, what we're supposed to start. We start at index 1. So if you want the first entry in an array, you write x, and it is parentheses instead of square brackets. So it is x parentheses of 1. It will give you the first entry in x. Now, you may specify multiple indices if the object you're dealing with is multi-dimensional. So if I take a look at this x in here, all right, so let's take the semicolon so we can see it. We're going to comment out those temporarily in here, and let's run this code. And x is a 2x2 table, 2x2 matrix that contains on the first row 3 and 5. And then after the semicolon, it means that we have another row. This is going to be 7 and 9. And when we try to, or when we want to, we specify x parentheses 1, 1. Actually, we're looking for the first row, the first column entry, and this is equal to 3. Now, if you want the 2x1, and we execute it in here, you're going to see that this is the row 2, column 1 entry, and this is 7. Of course, we can try to do that for the 2x2, and this is going to be the entry in here, the second row, the second column. This is the entry 9. Now, even through indices or in indexing, we can use the slicing operator. We can use the column, and this is going to mean a range somehow. So if we say, again, x is, let's display it. I'm going to take semicolon off, and when we execute this, x is 1 row, that is 1 and 2. The second row is 3 and 4. And the third row is 5 and 6. So you can see x in here. And if you would like to see actually the whole second column, so we just specify column in here, and we put 2, which means I want to see the second column. And you can see it in here. The second column is 2, 4, and 6. The column in here means that we're selecting everything. If you want to see the first row, we're going to specify this is the row that I'm interested in. And then in here, I'm saying, give me all the columns, and we're going to see that I get 1 and 2. And of course, if you write x colon, then actually we're going to see everything, because I'm choosing all the columns, I'm choosing all the rows, right? And if I do x2 colon, then I'm going to get the second line. Okay. So when we write column in the indexing operation, we mean actually we want everything, all the indices. But also we can use it as a range. So I can say, I would like to see the range of lines from 1 to 2 and the first column. And let's execute this. So the object x, we had it above. So let's take a look at it. Here is x. I would like to see 1, 2, 3, 4, 5, 6. If I would like to see the first 2 lines and the first column, this is going to be 1, 2 is missing, 3 in here. So I'm selecting the first 2 lines, the first column, and I could have selected the first 2 lines, let's say the second column. Right? So I'm going to get the second column in here. If you want the lines from 2 to 3 and all the columns, then this is how it's going to look like. We write 2, column 3, comma, and this is the second index in here, going to be that of the columns. So we put a column to indicate I want the whole range. I want all indices in here. And finally, before we finish with this lecture, let's talk about how to save data in Matlab. And we're going to do it through an example. So let's say you would like to save the data of a sign, the value of the function, the sign function. So we're going to create data that's going to call sign data. We're going to specify it. We're going to start with zeros. And here we're going to say number of rows, 2 rows and 1,000 columns. All right. So I have simply 2 rows of zeros. Now, the first one in here, we're going to fill it with data that is from 0 to 2 pi, 1,000 points. So we use the linspace function. This is linspace 0 to pi 1,000. So these are regularly placed 1,000 points starting at 0, ending at 2 pi. This is going to be kind of the x-axis from 0 to 2 pi. Now, the second row in here is going to be the value of the sign function. And listen, here you can see the powerful, how arrays are being used in MATLAB. What is the power in MATLAB in here is that we can actually use arrays altogether. So we can write sign of, and we specify the whole first row. So give me the first row, so first row and column in here. We pass it as an argument to the sign. The end result is going to be placed in the second row. So this is an array operation, which is really great. And actually, MATLAB will allow you to do these array operations almost on every. Okay, so the second row will contain the value of the sign function. And here I will have in sign data, 2 rows. The first row is the x-axis from 0 to 2 pi, and the second row is the y-axis, which is the value of the sign. How do I save this data? Well, I simply use the function save, and I specify save data. All right, so I'm going to execute it in here. So this has been executed, and we saved sign data. So now, actually, if you check your directory, you will see that there's a file called signdata.mat. All right. So how do I load it? The function clear. Let's do it one step at a time. I'm going to comment these things out. All right. So whenever we write function or we execute the function here, we clear the workspace. I mean, there are no more variables. Let's do just see it firsthand. If I write to see, okay, what are the variables I have? Listen, for the moment, we created while we're toying around above with all of these entries in here. Now, if instead of doing this, we clear first, and then we try to figure out. All right, so let's execute this. If we clear in here, and then we say, okay, what are the variables? As you can see in here, nothing. We don't have any variables because we cleared the workspace. Okay, so how do I get the data that has been stored? We use the function load. So we write load and then the name of the file without the .mat. I mean, if you save send data, sign data, then you load sign data. And here we're gonna be loading sign data. Now, if we write whos, you will see that there is a variable called sign data. Actually, the first row, we're gonna make it X. The second row, we're gonna make it Y. And let's actually plot. How do we plot in MATLAB? We use the function plot, and we specify the array that is the x-axis versus the array that is the y-axis. That's it. Now, we write pause and close in here. It's simply saying, okay, plot this diagram, wait for something, some entry on the keyboard, and whenever something or the user enters something, close the picture, close the figure. So when we execute this, a figure is going to pop up, and we're going to see X plotted versus Y, and then whenever we hit a button, the figure will close. So as you can see it in here, we plotted a sine wave from over axis from 0 to 2 pi, right? So we use the plot function in here. Okay. In general, for any function of interest, if you want to learn about something about specifically the syntax, the parameters that can be passed, how can we do this, you can use the help function. You can simply write help and specify the function you're interested in. So in this case, let's say I would like to know more about how do I load files. So I write help space load, and when I execute this, I get the help I'm looking for. And as you can see it in here, describes what is the syntax, file name, variables. It gives you all the options. We can specify, for example, this is an ASCII file versus a binary file, .mat file. All right, so you can read all of those in details for any function. And then also it will tell you actually there are some other related functions, like save would be related to load, mat files, whos, clear. So It will also try to recommend or at least list things that are related. So this is when it comes to plotting, simple plotting, actually saving a file, in addition to looking at this basic type in Matlab, which is that of array, which in general is n-dimensional. It will encompass matrices as well.